Hey, Professor Sarter here. I am working on question 16 from the practice test. The directions here say solve the rational equation, -6/p plus 1/3 equals -5/p. So a rational equation is going to be an equation that has variables in the denominator. You can see that we have p in the denominator here. When we solve a rational equation, what we need to do is get rid of all of the denominators so we can proceed to solve. So to get rid of the denominators, we're going to use a method called clearing fractions. And when we clear fractions, you're going to look at each denominator and figure out what a common denominator is, or least common multiple. So the least common multiple needs to be able to cancel out each of these denominators. So it has to have a factor of each of these denominators within it. So it needs to have a factor of p, so it will cancel out that p in the first fraction. We also need a 3 as a factor, so it'll cancel out this one. We already have a p to cancel out this one. We can use the same p to cancel out this one. So our least common multiple will be 3p. Once you figure out what that least common multiple is, what you do is you multiply both sides of the equation by that least common multiple, and you can sort of simplify it a little bit, multiply every term by that least common multiple. So you're going to multiply 3p times the first fraction times -6/p. Then you're also going to do that common multiple, 3p times 1/3, and then 3p times -5/p. So we multiply that common multiple times every term. So once we do that multiplication, we should see all of the denominators cancel out. We have a common factor of p in the first term. Multiplying by p and dividing by p are opposite operations, so they cancel. In the next term, the multiply by 3 and the divide by 3 cancel each other out. And in the last term, multiply by p and divide by p cancel. So we're going to write down what's left. In the first term, we have 3 times -6, which is -18. In the next term, we have p times 1, which is p, and in the last term, 3 times -5 is -15. Now we're going to solve the equation that we have left. So the equation that we have here, I notice the variable p is to the first power. This is a linear equation, and I'm going to solve for p, getting p by itself. I'm going to add 18 on both sides. This gives me p equals 3. Now there's one more step that we need to do here. Usually checking is optional, but we have to make sure that we never created an undefined number, which is creating division by 0. So we have to make sure that when we substitute this in for that denominator, for that variable, that we don't get 0. In this example, we would get a denominator of 3 in both cases, which is allowed. Division by 0 is not, so we just have to make sure that we never divide by 0. So the solution to this equation is p equals 3. All right, with number 17, we are again solving a rational equation. This time the equation is 3p over p squared minus 1 plus 2 over p minus 1 equals 1 over p plus 1. So with rational equations are equations that have these variables in the denominator. What we need to do is get rid of all the denominators. We're going to use the clearing fractions method to do that. Before we figure out the least common multiple, which is the first step in clearing fractions, we should factor each denominator completely. The p minus 1, so this denominator here, is already in factored form, and so is this one. The only one that we need to factor is the p squared minus 1. So for that first denominator, p squared minus 1, there is no greatest common factor. And I can see that there are two terms with the squared. This is a difference of squares. One of my special factoring patterns, we have p plus 1 times p minus 1. So we factored that denominator. And once we have it in factored form, we're going to be able to find our least common multiple. So for our least common multiple, what we need to do, we need to be able to cancel out each one of these denominators. So in order to cancel out this denominator, I need a factor of p plus 1 and a factor of p minus 1. So my least common multiple is going to be p plus 1 times p minus 1, and this also takes care of the other two denominators that we have. So that will cancel out the p minus 1 and the p plus 1 as well. So once you figure out what that least common multiple is, you're going to multiply every term by that least common multiple. So the first 3p over p plus 1 times p minus 1, we're going to multiply that by our least common multiple, p plus 1 times p minus 1. The next term, 2 over p minus 1, times the least common multiple, p plus 1 times p minus 1. And the last term, 1 over p plus 1 times p plus 1 times p minus 1. So we multiply our least common multiple times every term. So then we're going to cancel out the common factors here. So we canceled out p plus 1 and p minus 1 from the first term, p minus 1 from the second term, and p plus 1 from the third term. So we've got all our denominators canceled, and let's write down what's left. So in that first term, the only thing left is 3p. In the next term, we have 2 times p plus 1. That's 2p plus 2. And on the other side of the equation, 1 times p minus 1 is p minus 1. So I'm going to combine like terms. This is 5p plus 2 equals p minus 1. We once again have a linear equation because my p's are to the first power. I'm going to collect them, so I'll subtract p. That's 4p plus 2 equals negative 1. Now I'll get p by itself, subtract 2. 4p equals negative 3. And finally, divide by 4, and p equals negative 3/4. So zooming out for a second here, there's one last thing that we need to double check. We need to make sure that we never make the denominator equal 0. So if I were to substitute this negative 3/4 in for p, I don't get a 0 in the denominator. Division by 0 is undefined, so we just have to check for that. For this one, we never get a 0 in the denominator, so we're going to be able to keep that solution. So for question 18 here, we want to simplify the radical. We have cube root of 192. So to simplify a cube root, it would be a good idea for me to be familiar with perfect cubes. So let me write down a few perfect cubes. We have 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125, 6 cubed is 216. Now it's okay if you don't know these off the top of your head. You can use your calculator to help you. I'm just double checking. 6, okay, 216. So I stopped there because 216 is bigger than 192. So I can see that 192 is not a perfect cube. So since I can't simplify this cube root 100%, what I want to do is factor 192 as one of the factors being a perfect cube. So I want to use these perfect cubes to factor 192. So in my calculator, I'm going to do 192 divided by 8. And that does go evenly. So let me write that down over here. 192 is 8 times 24. But when you factor it into a perfect cube, you want to make sure that you get the biggest perfect cube possible. And by looking at my other factor here of 24, 24 I know is 8 times 3. So there's another perfect cube that's bigger than just 8. So I'm going to go to this one here, 64. So 192 divided by 64. That's 64 times 3 would give me 192. So this is what I want to use to factor 192. So cube root of 64 times 3. And the 64 is a perfect cube, so I'll be able to simplify that. Cube root of 64 is 4. And the 3 is not a perfect cube, so the 3 is going to stay inside the radical. 4 cube root of 3. All right, number 19 here is simplify 6 times the 4th root of 256x cubed completely in radical form. Assume that x is greater than 0. Okay, so we want to simplify a 4th root. So it'd be good if I get familiar with perfect fourths. So let's write down some perfect fourths. 1 to the 4th is 1. 2 to the 4th. 2 to the 4th. I'm getting out my calculator here. 2 to the 4th is 16. And 3 to the 4th, I believe, is 81. Let me double check. Yes. Okay, so then 4 to the 4th is 256, and that's the number that I have underneath the radical here. So I'm going to be able to simplify that number part of the radical. So let's carry down the 6, and the operation going on in between the 6 and the radical is multiplication. So I'm also going to carry down that operation. And the 4th root of 256, we just figured out that that's 4. And I'm going to leave this variable part inside of the 4th root of x cubed. Now the reason why I'm leaving that inside of the radical is because the power on x is lower than the index here. If this power on the variable was higher, then I'd be able to simplify that radical. But since it's lower, we're going to leave that alone. So to finish simplifying this problem, we'll do that multiplication. 6 times 4 is 24, and the 4th root of x cubed. All right, question 20 here, we have simplify completely. -3 square root of 50 plus 8 square root of 2. So here we're adding radicals together. In order to add or combine radicals together, we need to have like radicals. That means they have to have the same index. Both of these are square roots, and they have to have the same number under the radical. So these are not like radicals. Right now we cannot combine them together because they have different numbers underneath the radical. But I can try to simplify the radicals, and maybe they'll be alike once I simplify them. So I'm going to simplify the square root of 50. Now, since this is a square root, we use perfect squares to simplify square roots. So let's write down some perfect squares. 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64. So you can see that 50 is not a perfect square. So we want to try to factor 50 into a perfect square in some other number. So I know that 25 goes into 50. So I'm going to write 50 as 25 times 2. So we have minus 3. And the operation in between the negative 3 and the radical is multiplication. And I'm going to rewrite that 50 as 25 times 2. And I'm just copying down the 8 square root of 2. And the square root of 25 is 5. We're going to multiply. We're carrying that operation of multiplication down. And we leave the square root over the 2 because 2 is not a perfect square. We weren't able to simplify that part. So we're now multiplying. We have negative 15 square root of 2 plus 8 square root of 2. And now you can see that we have like radicals. And when we have like radicals, we can combine them. And we're going to do the math on the coefficient. So we want to do negative 15 plus 8. That's going to be a negative 7 square root of 2.